Hey guys, I'm Sarah Bendrick. I'm a landscape contractor, but today we are talking about a very large deck, and I brought my buddy from Simpson Strong-Tie. This is Scott Fisher, and he is a licensed engineer. And today I want to go over some of the connections and some of the fasteners that we're using on this deck in particular, why they're important, and just a little bit more information about them in general. All right, so starting with a big deck like this, we usually start with our footings and making sure that those are poured. We're on a very steep slope here, so there's some calculations to make sure that those footings are deep enough, but maybe one of the most important things is the post connection to the concrete. So can we talk a little bit about that?
Absolutely, yeah. So let's kind of just in general, as we're looking at the post. So first thing I want to point out before we even get into the footing is the post size, right?
Yeah.
Here we're looking at a 6x6 post. And this is going to be code-wise, or at least the residential code-wise, is going to require a 6x6 post. So that's the first thing to note. Now, as you're engineering it, if you do have a condition such as this, where it actually is designed by an engineer, the engineer is likely going to design the 6x6 post. But key to note, you're typically going to see that size of a post. And now as we look at the connection that we drop the post into, that's going to be a post base. Yeah. So in particular, this is the CBSQ 66.
Yeah.
So this is a post base that is wide enough to take that 6x6 post, right? It's connected with our SDS screws. It's sitting in the seat that is actually 1 inch stood off from the base of the foundation, right? We talked about the idea that you don't want to have your post bearing directly on bare concrete. One, for the rot that could occur in the post if it's going to suck up that.
Because concrete holds moisture.
Absolutely,
and that's going to suck up to the wood.
It could.
Or with what we had in this deck in particular, is that the wood was on the concrete, but it was also buried by dirt because the slope had been eroding onto it.
Even if you have a pressure treated post, you still want to be able to prevent that moisture from getting in there. And then the actual post base, that post base is going to resist the forces. One, download, right? We know the download force because that's the weight of the deck, right? That's going to be the weight of the wood. It's going to be if we're up there having a barbecue, all those things. But also as the wind blows, as the earthquake comes, as the snow drifts up against it, lateral loads. So you have downloads, you have uplift loads, and you have lateral loads. So that post base is helping resist all of those forces.
Right. No, and I think there's a lot of different options when it comes to post base. Because this is kind of under the house on the backside, we went with strictly functional, but there is the accents that you guys have, which are powder coated?
Yeah, so exactly. So those are kind of the, I'll say the very aesthetically pleasing series of connectors we have. And those are powder coated, like you mentioned, black. Those look really nice.
They do.
We don't have a CBSQ in the outdoor accents. In most cases, you're going to see the outdoor accents being what's considered a post-installed connector. Yeah. And that would be a connection in the concrete where you pour your concrete and then you come back after it's cured and you drill a hole. You add your post-install base, and then you add the anchor down through it.
Yep.
So that's going to be, one of the things you're going to find with the outdoor accents.
Sure.
The CBSQ, as you pointed out, is taking kind of higher loads. We do have both the higher down loads, higher uplift loads, higher lateral loads. So this connector is going to be kind of the most appropriate connector from an engineering standpoint for this application.
Sure. And then you mentioned at one point also with the hot dip galvanized versus the Z-Max versus a stainless steel that you want to make sure that the hardware all connects and is the same finish.
Exactly. Yeah. So like you just said there, we want to make sure if we're using a hot dip galvanized connector, we want to use the same fasteners.
Yeah.
You don't want to have, for instance, a hot dip galvanized connector and a stainless steel fastener. You want to make sure you have the same coating. As we talked about earlier, with the properties of the pressure treated wood, if you have the high levels of the preservative treatment chemical that's in the wood, and you add a hot dip galvanized fastener, you could have issues with corrosion in those cases. So it's one of those where there's not kind of the perfect combination. You just need to be aware of what it is. We've got a really good description of it in our deck connection and fastening guide. It's basically a table that kind of is a recipe. All right, if your preservative treatment is this level, then you should use this fastener. If it's this level, then you need to be, stainless steel, whatever it may be. So just kind of be aware of your, basically the environment as it pertains to the preservative treatment your fasteners and your connectors.
And that's why you either want to have an engineer, an architect, a contractor, all on board that know what they're talking about when it comes to a build like this.
Absolutely, yeah. You want to make sure that they know what all those coatings are, what the preservative treatment is, and then consult as a homeowner or as a builder, consult with those professionals so you know what you're getting.
But the information is out there for those DIYers.
It is.
It's just a little bit more work. You really got to know your code and you really got to understand construction. But it's there if you're willing to do the research.
Totally, yeah. And if you read through that deck connection, we were just,
it's actually a really nice little book.
I shared one with you yesterday, and we were going through it and kind of looking at the different, the different features that are in that guide. So just kind of be aware and know what's in that information.
All right, so we started talking about the post base, and now I want to talk about post caps or the connection to the beam that connects our posts so you can continue to build the deck.
Perfect, yeah, and you described that perfectly. Yeah, you get to the top of the post, and you need to connect your beam somehow, right?
Yeah.
And the way you're going to do it is you're going to use a post cap. Here we're using the CCQ. If you're going to be down on the end, you're going to use the E, CCQ, E for end or edge.
That makes it easy.
You want to make sure you fill all the fastener holes. This one in particular is the SDS screws, very similar to our post base. Fill all the fasteners. You're going to have fasteners that are going to be going on the strap that encases the post. And then you're going to have fasteners that are going to go in the saddle that are going to go into your beam. So that's going to support that beam on top of the post, just like the post base, uplift, download, lateral load. And again, it goes back to that proper connection. We want to make sure you have that connector to take all those forces.
Unlike the one that we started with, I don't know if you saw that before video, where they were just toe-nailed in, the beam was toe-nailed to the post, and it had slipped out. And so in the meantime, some 2x4s were kind of nailed on there. It definitely was not secure. So this really helps hold it in place.
Absolutely. And that goes to one of the warning signs we talked about earlier, right?
Yeah.
If you don't have a proper connection or if you have a missing connection or connector, that's the thing, again, as homeowners, we want to look for. Yeah. But when you have this, obviously a new build, everything to code, you have your proper connection, again, the CBSQ at the top of the post.
Got it. All right. So now that we have our post caps and post ends, I think the next thing we should jump to is probably the H1Zs.
Yeah. So here the joist is running over the top of the beam. So how do we make that connection?
Yeah.
Well, here we're like you pointed out, we're using the H1Z. So we want to make sure that, again, we don't want to have any rust on that connector. So we have the Z-Max for that connector. And what that's doing is it's fastening to the side of the beam, and it's also fastening to the side of the joist. So what you're getting is, we go back to the load path, right? When the wind wants to blow up here, or if you have any sort of uplift as a result of the cantilever that's out here, and the cantilever is the kind of the overhang over the beam, you want to make sure that that joist is not lifting up off of the beam. If you're going to be out on the end of your beam, you're going to use an H2.5Z.
Yeah.
So again, those are just kind of a couple different ways to be able to fasten your joist down to your beam.
Yeah, because I know in the catalog there's a handful that we could have used, but the H, I guess we should point out, is for hurricane.
Correct. Yeah. Yeah, those are hurricane ties. So
which we don't have out here. So why would somebody like myself in Northern California want a hurricane tie?
Yeah, no, that's a great question. The main thing is, and very good point. Yeah, that is H for hurricane. The thing with you're getting there is, when we talk about, say, hurricanes, it's actually related to the wind and the uplift that you would get. So in a condition like this, you're on the hillside, or even if it's in a flat condition, there's high potential you're going to get wind. Once you get your decking and any sort of covering on your deck platform.
It can be a sail.
Yeah, it's basically a sail, right?
Yeah.
And so right now on this beautiful day, we're not having any wind at all. But in the winter, you may potentially get those high winds that want to push your deck up. So the H, the hurricane aspect of it, it's really just holding down your joist to your beam. We want to make sure we have a continuous load path, and that means all the forces are being transferred down to the ground. And this is just one of the means and methods of being able to create that continuous load path.
All right, so let's next talk about the joist hangers. But first of all, for the original deck here, they did have joist hangers, but they were tied directly into the siding, which is not necessarily recommended.
Yeah, not a good thing. I mean, like you're pointing out, there likely was not a ledger. There may have been joist hangers, or there were joist hangers, but if those were just nailed to the side of the structure, kind of a no-no.
Sure, there was internal beam inside that it was connected to, but still, it's not like proper construction and what would be recommended now.
Yeah, I would relate it back to the improper connections, improper fastener sort of thing. And I guess if we just, again, keep it to the ledger right now, we talk about the continuous load path. The ledger is going to be one of your most important connections, right? Yeah. Because the ledger is literally tying this entire deck back to the house.
Yeah.
This is your main load path, back to your structure. So you want to make sure that that ledger is tied back to the structural part of your home, right?
And this is one of the biggest fail points potentially and most dangerous.
Yeah, unfortunately, yeah. What we see is this is the most common mode of failure. And when that ledger comes away from the home, in general, your deck, you're going to have a complete collapse.
Yeah, with a deck this high off the ground, that could be a catastrophe.
Absolutely, yeah. You have this steep slope here. So again, number one connection, let's make sure that the ledger is connected back to the house using the proper code-approved connections. And that's going to be, lag bolts, through bolts, Simpson Strong-Tie ledger connections, any sort of proper code-approved connector, fastener that ties the ledger back to the home. That's the number one thing you want to make sure that you're getting. And there's a lot of detailing that goes into that. And in our that connection fastening guide, we have a lot of details that show you how to connect that ledger back to your home.
So which joist hangers did we use and why?
Yeah, so these are the LUS 2.8s. So the LUS is a light joist hanger. It's taking the 2 and the 8 refer to the width of the joist hanger, right? We know that the width of the member, typically if you have a solid sawn, it's going to be 1.5. And again, the code does require this proper positive connection back to the ledger using the joist hanger. The code does talk about a proper seated area where that joist can sit in, and that's achieved by using this LUS 2.8 or any other various joist hangers that we have. Okay, we talked about the joist hanger. Again, we're making sure that the joist is fastened back properly to the ledger. The ledger is your connection back to your home. But what happens when the earthquake comes? We talked over here about the wind. The wind could uplift. The code requires that deck is tied back to the home to resolve any sort of lateral forces. And so what does that mean? It means when the deck wants to pull away from the home, how do you hold that back? Here we have DTT1s.
Okay.
We, as products, we have a DTT2 and we have a DTT1. The code requires that it needs to resist a force of 1,500 pounds. So the DTT2 resists 1,500 pounds. The DTT1, 750 pounds, right?
Yep.
So it's half of that. So basically, you're kind of doubling up the number of these. But the advantage you get with the DTT1, which again is what we have here, is you're able to use the screw that comes along. It has a really long screw with 3 inches of embedment at the end of the screw, and you can actually tie that back to your home without having to go underneath and tie to the rafters.
Got it.
All you do is you tie that back, and then you fasten the DTT1 to your joist. And again, for this run, you would have a total of 4. It would tie the ledger back, and then you're meeting the code.
So if you had a completely finished house on the inside, you don't really want the DTT2 in a way, because you would have to either open something up to do that. So the DTT1 would be more appropriate. You just need more of them. Did I get that right? Okay.
You got it right. And we're going to see the DTT1 in really conditions like this, where it's an existing home. Like you mentioned, you don't want to go underneath there, break open your ceiling to try to find a connection. Now, the DTT2 is a very fine connector, and it resolves that force. It's a higher loaded one. But again, you would need to have one on the outside, one on the interior. You would run a through bolt, a threaded rod, and you would connect the two. With this, you literally just kind of pinpoint where your double top plates are, or your studs, any sort of solid member that has at least 3 inches of embedment that you can get the screw in. And then you have your adequate load path connected.
Embedment, that's a good word. I was going to call it meat.
Yeah, the embedment, that's fine too. Yeah, I mean, the bottom line, you want to make sure that you're tying your deck back to the home, so when those earthquake, wind, lateral forces occur, you're tying the deck back to the home.
Awesome. So we talked about a few different parts. The DTT1s, we have the joist hangers, and then we have, of course, the H1Zs, and we have our post caps and post bases, and all of those are Z-Max.
Yeah, so all of the connectors up here are Z-Max. So the joist hanger, the H1s, the post caps are actually hot dip galvanized, and the post bases are hot dip galvanized. So all it is just that kind of that extra little level of corrosion protection. Now at the post bases, obviously this is going to be a case where you're potentially going to have more soil, water, whatnot. But the main thing to know is you want to make sure you have the proper protection on your connector and fastener to protect against the exposure that you're going to have.
Got it. And so just to reiterate, that Z-Max is recommended as a protection.
Yep.
But the next step up would be hot dip galvanized, which we have at the post base and post cap.
Yep.
And then if we went even further, it'd be stainless steel, but that gets quite expensive. So you're not going to do that unless it's probably required, or you're in an area with a lot of salt, which is whether that's on the ocean or somewhere where you're throwing salt from snow.
Yeah, and those are a couple of the occurrences. But yeah, you're going to have Z-Max, hot dip galvanized, stainless, kind of in that order in terms of the protection on your connector and fastener.
Awesome. So that all those are just finishes. The steel is all the same, or they guess.
In general, the steel is the same. Now, you're going to have different strengths of steel, certainly different thicknesses of steel.
Yeah.
There multiple specifications that you can look at. Usually we're going to use those specs when we're designing from an engineering standpoint, but in general, the steel is basically the same.
Awesome. Well, thank you so much for going over the different parts of the deck. I definitely feel like I have a better understanding. If you guys have any questions out there, go ahead and DM us below. And if I don't know how to answer it, I'm going to email this guy.
Perfect.
Thanks for coming.